Hey guys, today's lesson is on solving equations by factoring. The first four problems we're going to look at are in what's called factored form, in which the left side of the equal sign is written as a multiplication problem. As you can see, the right side of each of these equations is equal to 0. Before we begin, we're going to ask ourselves the question, if A times B is equal to 0, what can A and B equal? Well, if we have a product or a multiplication problem that's equal to 0, one of the factors or one of the expressions being multiplied to each other must be 0 for the answer to be 0. Therefore, we have two steps of solving an equation in factored form. What we're going to do is set the factors equal to 0, and then we're going to solve both of the equations to get our solutions. Factors are the expressions being multiplied together. The first factor for problem number 1 is x, since the problem is x times x plus 3. I'm going to set each of them equal to 0 in the first step. And for our second step, I'm going to solve both equations in order to find our solutions to the equation. The first equation, x equals 0, there's nothing to solve for, so I know my first solution is 0. And the second equation, we're going to solve by subtracting 3 on both sides to get our solution, x equals 3. For problems with more than one solution, we're going to put the answers in what's called a solution set. A solution set for this problem would be x equals -3 and 0, which we traditionally list the solutions from least to greatest. So the only numbers in the whole world that would solve the equation x times x plus 3 equals 0 are the numbers -3 and 0. Let's go on to problems 2, 3, and 4, in which we're just going to follow these two steps, setting the factors equal to 0 in problem number 2. Our first factor is x. And our second factor is x minus 2. Factors are the expressions being multiplied together in order to get a product. We're now going to solve both of these equations, in which the first equation, x equals 0, is already solved for x. And the second equation, we will add 2 on both sides, leaving us with x equals 2. Our solutions in our solution set, x would equal 0 and 2. This equation has two solutions. If x was 0 and we plugged it into the original equation, or if x was equal to 2, it would solve the equation, or the left side would be equal to the right side. In problems number 3 and 4, the factors are both binomials. The factors for problem number 3 is x plus 3 and x minus 2. Let's find the values of x that would make this equation true or solve the equation. I set both the factors equal to 0, and now we will solve. My first solution is x equals -3, and my second solution is x equals 2. My solution set will have the values -3 and 2 in it, showing that those are the solutions to the equation. Similarly, problem number 4, the factors are x minus 4 and x plus 5. We'll set them equal to 0 and then solve them. First equation, I will add 4 on both sides to get our first solution, x equals 4. And the second equation will subtract 5 on both sides to get our second solution, x equals 5. The solutions for problem number 4 is -5 and 4. The next few problems we're going to see are not in factored form. As you can see now, problems 1 and 4 at the bottom are just expressions. Some of them are 2 terms, or binomials, and 3 and 4 are 3 terms, which are trinomials. We need to first put them into factored form, so we're going to factor each of them, and then solve as we did at the top half of the lesson. So when we are asked to factor, the first thing we're always going to look for is a GCF. Is there a number that goes into 3 and 6? Yes, there is. The GCF so far is 3. Do these two terms have anything else in common in terms of variables? They both have an x. Our GCF for these three terms are 3x. Therefore, I'm going to factor by dividing both of the terms by our GCF and writing our factored form of the binomial as the GCF 3x times whatever we get after we divide. 3x squared divided by 3x is x. 6x divided by 3x is 2. This purple equation is now in what's called factored form. Factored form is basically rewriting the expression as a multiplication problem, in which we're now going to set the factors 3x and x plus 2 equal to 0. We're going to solve those two equations individually and find our solutions to the equation. Solving the first equation, 3x equals 0, we'll divide 3 on both sides of the equation, giving us one solution of x equals 0. And the second, we'll subtract 2 on both sides to get our solution x equals -2. So our solution set will have -2 and 0 in it. We could always double check to see if these solutions are correct by substituting them back into the equation for x and making sure the left side is equal to the right side. Problem number 2, let's go on to factoring this expression first. Is there a GCF for these two terms? Do they have anything in common? No, they do not. The next option that we're going to think about is, since there are two terms and it's a difference of two terms, this type of expression could be factored as using the difference of squares method. If we could write this expression as a difference of two terms being squared, we know that the factors would be a plus b times a minus b, where the first term being squared plus the second term being squared times the first term being squared minus the second term being squared. In this case, we could write the first term as x squared, and the second term would be 3 squared, since 3 times itself is 9. Our factors will be x plus 3 times x minus 3. We now rewritten the equation in factored form, or we rewrote the equation so it's a multiplication problem. We're now going to set both factors equal to 0 and solve each individually to get two solutions. Our two solutions in this case, solving both of the equations, will be -3 and 3. Our last two problems on our page, number 3 and 4, are now trinomials. Both of those expressions are 3 terms. So we have to think about the factoring methods that we could use when we have 3 terms. Notice that in problem number 3 and 4, there's no GCF for all 3 terms. They don't have anything in common. Problem number 3 is in the form ax squared plus bx plus c, as well as problem number 4 is as well. The difference between the two is that the a value, or the leading coefficient, in problem number 3 is 1, and in problem number 4 is not 1. It happens to be 2. So we're going to use 2 different methods in this case to factor. We're going to rewrite the trinomial as a multiplication problem. We know when we have a trinomial and the leading coefficient, or a, is 1, we need to find 2 numbers that have a product of c, which in this case is 5, and a sum of b, which in this case is 6. Since I know 5 times 1 is 5, and those digits add to 6, these are the pair of numbers that we're going to use to write our factors. When we're factoring a trinomial, our factors will be 2 binomials, in which case we will have x plus 5 times x plus 1. Remember, we could always double check to see if our factored form is correct by multiplying x plus 5 times x plus 1 and making sure we arrive at our original expression. Now, continuing to solve, we'll set these two factors equal to 0, solve both equations individually, and get our solutions. Our two solutions for this equation would be -5 and -1, such that when we're solving x plus 5 equals 0, we'll subtract 5 on both sides to get our answer -5. And lastly, solving x plus 1 equals 0, we'll subtract 1 on both sides. Our last problem here, problem number 4, again, our a value or leading coefficient is not 1. So we need to use a different method in order to factor. I want to rewrite this expression or this trinomial in factored form or as a multiplication problem. The first step, since we have an a value, is to slip it over and multiply it times c. Our remaining trinomial will be x squared plus 3x plus 2 equals 0. We're going to continue to factor our new trinomial as we factored problem number 3. We're looking for two numbers that have a product of 2 and a sum of 3. Those two numbers would be 2 and 1. Since 2 times 1 is 2 and 2 plus 1 is 3, our factors are x plus 2 and x plus 1. Since in the first step we multiplied by our leading coefficient, we're now going to divide by our leading coefficient and simplify the fraction if we could. For example, the first factor, 2 divided by 2, is 1. Therefore, we have x plus 1 times our second factor. We're left with the fraction 1/2. We're going to slide the denominator up to the front and get our second factor as 2x plus 1. We're now going to set both of those factors equal to 0. X plus 1 equals to 0. 2x plus 1 equals to 0. Solve both of the equations and transfer our solutions in our solution set, representing the answers or solutions to the equation. Solving will give us our two solutions, -1 and -1/2. What I'm going to ask you guys to do is try number 1 through 4 on our second page. What you're going to have to do is factor each equation and then set each factors equal to 0 in order to find its solutions. Once you get your answers, play the video back to check. Here are our answers for problems 1 through 4 on our second page. Problem number 1, we're factoring using the GCF of 2x. Setting the factors equal to 0 will give us our two solutions, -5 and 0. Problem number 2 has no GCF, in which we could write that expression as a difference of squares. Our factors would be x plus 10 times x minus 10. Setting those factors equal to 0, we'll get our solutions -10 and 10. Problems 3 and 4 were both trinomials with no GCF. Problem 3, we're finding two numbers that have a product of -10 and a sum of 3. Those two numbers happen to be 5 and -2. Setting our factors equal to 0, we arrive at our solutions -5 and 2. Problem number 4, factoring a GCF where the leading coefficient is not 1. Remember, we are slipping the a value over. We're multiplying times the c. We're then factoring the new trinomial and then dividing by 2 in the end, arriving at our two factors, 2x minus 1 and x plus 2. Setting the factors equal to each 0, we get our solutions -2 and +1/2. Please let me know if you guys have questions on the lesson, and I'll talk to you soon.